Okay, so once again, welcome to off-season training week 1 for programming. So today we're going to be covering the more introductory things. We're going to be starting with a quick recap of Java, and then we're going to be looking at motors, sensors, and controllers just to a basic extent. All right, Sean. Okay, so first, most of you have been here and have seen what an FRC season looks like, but for those of you unfamiliar, we're not ready for that yet, Sean.
Oh, sorry.
So for those of you who are unfamiliar, an FRC season is every year, starts in January. For 6 weeks, we design, build, and program a robot just from scratch. And there's a lot of different sub-teams that are responsible for that, right? So there's mechanical, electrical, CAD, scouting, strategy, etc., also media. But we're going to be doing programming stuff, which, you know, my kind of thing, and everyone's here for that. So that's what we'll be learning about. All right, Sean. Sean. Okay, so here's where we are right now. We're at week 1. So we're going to be looking at early on stuff today. Java's important, and then just basic things. As the weeks go on, we're going to be tackling some more challenging concepts, and hopefully by the end of this, you have this robot, which is going to be your friend right here, this tank robot over there. That should be competition ready. Not really, but it'll be, you'll have learned quite a bit more than you know right now, hopefully. So now we're going to move on to the quick Java review, and quick is the key word here because, in my opinion, the programming the robot parts are a lot more interesting than learning Java, and hopefully all of you at least have some prior experience with programming, so this should be not that big of a deal. So I want to get through it quickly, but Sean, if you want to move on, we'll look at what we're going to cover. So we're just going to go over some variables, right? Loops, conditional statements, things like if-else, methods, and then classes at the end. That's all we're going to be doing. There's obviously more things like arrays, but that's not what we're covering today. The goal is just to get you familiar so you can move on. Okay, so variables. What is a variable? Variables store some data. They contain some data. There's different types. In Java, there's different variables called, for example, a string. That's going to be text. So, for example, Krypton Cougars would be a string of text. Ints, short for integer, stores 1, 2, 3, 4, or -1, 0. Yeah, it's amazing. Double, a decimal place number like 1.5, and a Boolean. That's going to be useful for something like the robot where it has a sensor that might be true in one position and false in another. And we want to store that. That is what a Boolean is for. Sean. Okay, so declaring a variable is pretty simple in Java. First you give the type of the variable, then you give it a name, and then you give it a value after an equal sign, and then a semicolon. Semicolon's important. You will have errors without semicolons, so make sure you do those. Now, if you notice here on variable name, the N is capitalized. That's something called camel case. Different languages do it differently, but in Java, you use camel case for variable names. That's just a standard thing. So that means that every word after the first word, you capitalize the first letter. So here's an example of how you would declare a variable, a couple different ones. So int my equals 5, right? We already discussed integers. String my string equals Krypton Cougars. Notice the double quotes. Those are required for making a string. And then the semicolon at the end. All right, Sean, you can move on. So there's also final variables. This is something that is useful for robotics because we often have constants for a robot. For example, we want to store the length of the robot, the width of the robot, the radius of the wheel, things like that. And final is useful because it allows you to define something as unchangeable or immutable. So there's no reason to change those values. And in case of an accident where you try to, you would get an error. So you would know that you're doing something that's going to cause a problem. All right. So here's your first opportunity to use those papers and pencils. So what we're going to want to do is create some variables. We're going to want to store your name, right, in a variable, your age, and the probability of a coin landing on heads as a decimal, okay? And any of these variables that will never change, right, there's no reason they would ever change, you want them to be final. And then we're going to print these values using system.out.println.
Yeah, try making it smaller, because then it might cover more.
And also, I should say, for these examples, we're not going to be spending a whole lot of time, so it's okay if you don't get every single thing done if you're confused. We're going to be showing a solution on the next slide after you're ready, and I'll gauge when that is.
I mean, I would say RAV, but that's going to be a long time.
I don't know if there's another option.
I mean, this is an 11-hour print to start with.
I don't know.
It prints up in 2 hours, but
I don't know why we're not. And the other thing is we're not going to be here, so it doesn't matter.
I'm just concerned with 101 grams. I assume we use them for grams.
No, he's not. Actually,
Oh,
I think he's. No, this looks like a kilogram.
yeah.
I know I've seen. Yeah.
Yeah, I typically use 500 grams because
I think some of them are 500 grams. I got a free kilogram when I bought my program, and I never.
I've run out of black, silver twice, and gold once.
Alright, I think that's good. It's okay if you didn't get everything done, but hopefully you at least got the concept of that. So Sean, if you can move on to the next slide so you can see the solution. So this is going to be an example solution. Again, you don't have to have everything done. You can just check which is what's on here. You can ignore this variable right here, but that is a Boolean. So notice how we chose certain variables to be final, some not. I noticed some of you chose your name to be final. That's okay. In some situations that would be, but you could also assume that sometimes people change their name. But the key one we did want you to notice could be final was probability of heads, because as long as you're flipping a fair coin, that probability is never going to change. But it's okay, you can interpret it any way you want. Then these prints, they're annoying, right? System.out.println, system.out.println every time. They're annoying, but that's just how we do it in Java. So this is what the output of that kind of code would look like, where your name would be right there. All right, Sean. So next we're going to look at loops, right? So loops, their entire point is to do something over and over again, just repeat. And there's two different types for two different purposes. So a while loop, the entire point of a while loop is to do something while a condition is true, that's the name. So for example, maybe we want to drive forward while something is detected by a sensor, right? So that would be a good application of a while loop. On the other hand, a for loop would be more useful if we want to do something a specific amount of times. For example, count from 1 to 10. It's very easy to make that list of numbers, and it's very well defined. So that's a good example of a for loop. All right, Sean. So first, let's look at a while loop. Okay. So the basic syntax is while some condition is going to go in there, and then those curly brackets contain whatever code you want to run repeatedly. Okay. So next, we're going to look at an example. Okay. So here's a basic example. We have an integer called I, and we're starting it at 1, and we're going to loop while I is less than or equal to 3. We'll get to those in a minute. That's just assume that's what less than or equal to looks like right now. And while that's the case, we're going to print out I, and then we're going to do I++. There should be a semicolon at the end of that, but I++ is shorthand for I equals I plus 1. So basically increase I by 1. So what was going to happen, right, is we're going to print out I is 1, then we increase it by 1 again, until that condition is met. So Sean, if you move on to the next. All right, so then this is what the output is. Pretty simple. But once it's 3, right, then we run it one more time, then it's 4, and we stop. Pretty simple. All right, we can move on to for loops now. So for loops are basically just a shortening of a while loop. So for that specific situation where you want to increment until a certain condition is.
Oh.
Okay, we're not getting. Okay, so no, it's fine. It's fine. So we have our while loop example next. So your first goal is to create a while loop that loops until your age. So basically your age number of times. Okay, and each time we want it to print out your name on a new line. Alright, Sean, we can go ahead and show the next one. So this is some code that will work in Java in particular. So notice age is 1, age is less than or equals 16. In this case, that's the age of our team. And then we print out the name and then age plus plus. I noticed some of you guys are programming in other languages, which is okay, just not in Java. So there's no semicolon here, okay? There's no colon here, it's just curly brackets. You don't need semicolon there either. So just make sure the syntax is important here. So that's one thing to keep in mind. Alright, Sean, you can move on to the next one. So for for loops are basically a shortening of what you just did. They allow you to do everything in basically one line minus the print statement. So if you move on to the first example, that I think shows it better. So in this first statement, we do the int I equals 0 thing that you already did. In the second statement, we give a condition, I is less than 5, that it will check every time. And in the last section, we have that incrementing, where we add 1 to it each time. So this will do essentially the same thing we did with the while loop, just in one line. So if you show what that will print out right here, it should print out 1 through 4 here. Okay. I think it would probably print out 0, but we won't worry about that.
Would I++ end with a semicolon? Or
No,
okay.
no.
Okay.
No, but this should probably start
It would
at
start
0.
at 0.
But other than that, we'll ignore that. Okay, so now it's your turn. You're gonna do the exact same thing you just did, just with a for loop. Hopefully it is a little bit shorter this time. Alright, I think we're good. So here's an example. Alright, we could start at age 0 and go up to 16 and do Krypton Cougars. Now, it says 16 times here. Quick tip. Typically, you're going to loop either from 0 to less than something, or from 1 to less than or equal to something. So this is actually going to run 17 times, not 16. That's a problem. So you would either want to start age at 1 and go to less than or equal to 16, which will go 16 times, or 0 less than 16. Okay? Typically one or the other. Anyway, we can move on. Sometimes it just makes sense to start at 1, sometimes it makes sense to start at 0. So now we're going to do conditionals. Conditionals are pretty quick. So less than, greater than should be pretty familiar. Instead of in math where you do greater than or equal to with the line underneath, you do less than or equal to and greater than or equal to with an equal sign after the symbol here. Equal to is a little bit different though. So remember before when we set variables equal to something, right? We used an single equal sign. It's very important that when you check if two things are equal, you use two equal signs instead. Otherwise, it will just set the variables, and that's not what you want to do. There's also not equal to, so A is not equal to B, and that will return true if those two things are not the same. Now, you can also use not as an operation on a Boolean. So if we have a Boolean variable called center active, something like that, and you put not in front of it, it would return the opposite of what that is typically going to be. So it would make true into false and the other way around. Logic, you've probably seen this before as well, but the two ampersands there stand for and. So if we have two Booleans, if that's true and true, it would result in true. But if either of these aren't true, then it would be false. For example, if we're trying to shoot a ball into a hoop, and we have two things that we're looking at. Is the flywheel up to speed, and is the button being held down? If those things are both true, we would want to do that. So that's a good application of and. Or, on the other hand, we'll do if either is true, it will be true, or if both are true. So it just works a little bit differently. All right, we can move on to the next one, if statements. So if statements, you've probably also seen these before. If, and then a condition in parentheses, it will run a certain set of code in those curly brackets. Otherwise, with the else, it'll run something else. So this is the foundation of most of the logic that we use. Sean? Okay, so looking at this example, we have two different Booleans here. Remember, true or false. Should be semicolons there. And then we check if my bool is equal to another bool. Remember the double equal sign to check that. So if they were the same, we would print they are the same. Otherwise, we'd print they are different. Now, since they are different, it should print they are different. And if we run that, then we can see they are different. Okay? Okay, so then there's also else if. This is just a quick thing. If you ever need to add another condition, so you want to check if something's the case, run something. If that's not the case, but something else is the case, you could use an else if, right, to add another option. And if neither of those things are true, then you could do else. And you can have as many else ifs as you want. Yeah. Next are methods. Okay? So methods tend to be a little bit more complex, but this is going to be the start of how we make our code easier to understand. So when we're writing code for a robot, for example, we typically like to separate out different sections of the robot into what are called subsystems. So we have a drive subsystem. We will also have an arm subsystem like on that robot, or an intake subsystem, things like that. Okay? So what methods do is methods allow us to do complex things like math, control motors, check sensor values, things like that, and hide all that complex logic into something just with a name, a method name. So a method takes in a parameter up here of some type or multiple, and it will do all that complex code inside of itself. So it allows you to hide complexity, which is often very useful when you don't want to be rewriting complex things over and over again. If you move on to the next one, we can look at some of these key terms here. So this is a method called add numbers that takes in num1 and num2. These are both integers, and it returns num1 plus num2. So what that means is it's just taking the sum of these two and returning that. So the end result of calling that method is that it adds these two passed in numbers together. Now public versus private. So in one of these subsystems, we have this complex logic, and sometimes there are things that you don't want to be accessible throughout the code, right? Sometimes there's a dangerous feature that if you called it at the wrong time, maybe something breaks on the robot. So that would be a good application of something private, where you don't want it to be called at the wrong time. Public, on the other hand, is accessible throughout the code, and that means that if you have something that's public, it's going to be more readily accessible. Next, if we have something that's static versus not static. Notice up there, that's not static, whereas this one is. Static almost means that it exists without context. So the only things that you need to add these two numbers together are just the two numbers themselves. Sometimes if you're thinking about doing something on the robot, you're going to be using sensors, right? And there's this context that's important to the decisions that you make. But if something's static, it means that you don't really care about context. So it's good for things like adding numbers, doing different operations that don't really require any additional context. All right, and then let's look at the next example. So
Can you please read out that example? I can't quite read it.
read this one out right here. Okay, so this says public static int add numbers, int num1, comma int num2. These are both curly brackets right here, and then return num1 plus num2, and then a semicolon.
Thank you.
Yeah, you can also move closer if you need to see. That's okay. Then example 2. So this is public void run motors. Okay, so void, that's a little bit different than what we just looked at. So this int means that we return an integer, and since we added two ints together, it makes sense that we would return an integer. But in this example, we're doing void. So void means we're not returning anything. Sometimes you don't need to, right? Some methods do something without actually needing to give anything back. So in this case, we're setting the speeds of these motors, but we're not actually returning anything. Now, if we look at this myMainMotor.set, myMainMotor is a variable, right? We already looked at that. And this is also a class, which we'll touch on in a second, but set is a method. So typically when you call a method, you're doing something dot and then the name of the method. And then these right here, this is where we pass in those values, right? So if we were calling, for example, add numbers here, this is called the argument that we're passing in. This is an actual value. And it would replace whatever's here and whatever's here in that method. So it just is inserted into that method. So we're setting one motor to drive forward at 50%, the other to drive backward. All right, we can move on to the next. So the final thing we're going to touch on in Java are classes. Okay, so what is a class? Well, luckily I actually already described subsystems, and typically in our robot and in the context of FRC, the first robotics competition, subsystems are one of the most common applications of classes. So a class basically is responsible for some tangible thing, typically. For example, managing one section of the robot. A class is typically responsible for something like that. And it, again, like a method, hides some complexity within itself. So if we look at these first two sections of our drive subsystem, which would be responsible for that drivetrain, first we have two things that look like variables, right? We have my motor and my other motor. Now, why are they private, right? Because when we did variables before, they weren't private. So why are they private? They're private because this is a class. Those aren't called variables, they're called fields inside of a class. And those are basically variables that are attached to that class. They go with it. And so we don't want the motors to be freely available outside of that class. But we want the drive subsystem to be entirely in charge of how we drive the robot. So if those were accessible outside, someone else could call that method, tell that motor to start spinning at a random time, and we don't want that to happen. So we want to keep that private. Next, we have this method called drive subsystem. This is a special method, and this is called the constructor method. This is always public, and it can take in parameters as well. But what it does is it sets everything up inside of the class. So this runs whenever we make an instance of a drive subsystem, when we make our drive subsystem. So we define what these two variables or fields that we made earlier actually are. So this one is a new motor, and we pass in something. We're passing in the ID of the motor. This is a common thing that you'll do. And what this does is it actually calls this new keyword and motor here actually calls the constructor method of motor, which is another class. So inside of our drive subsystem, we're calling another constructor of another class to make one of those motors, and we're giving it that ID. So it's setting everything up on inside with its own constructor. And finally, we have a method. So this is typically where methods are going to lie inside of your code, are inside of these subsystems or inside of something else, but inside of a class is where these methods are. And this one is a void, right? So it's not going to return anything, but it's going to set the speed to some percent output, okay? And then for each one of these motors, we're using that .set method, right? Because that class has its own public method called set that takes in some percent. So for each one of those, we're using that, we're just passing in that percent as a parameter into there. So yeah, I'm gonna stop for a second. Okay, so we just covered a lot of Java. So do you have any questions? Because this is where we're gonna start moving on to the next section. So do you have any questions about what you just saw? Because there was a lot of information. Okay, I'm taking this as this was too easy, or this is familiar. Is that the case? I think this is all relatively easy stuff. Okay, so that's good. So this is more interesting stuff, I promise. So now that we've moved on from Java, you can always ask more questions, but we're gonna move on from that for now. We're gonna talk about motors, controllers, and sensors, because these are some of the most core components of FRC robots and of programming. So this is going to be really important. So we use a lot of different types of sensors in FRC and also a lot of different types of motors. So on this robot, we're using motors called NEOs, right? And they are controlled by motor controllers called Spark Maxes, okay? On our competition robot, we use something called a Falcon with a Talon motor controller. There's some differences in the motors, but this is the one you're going to be familiar with because this is the one that we're using on this robot. So if we look at how we control a motor, first we initialize or instantiate an instance of this CAN Spark Max. Now I said it was called a Spark Max. CAN stands for the way that we communicate with the motor controller, which is not that important to what you're doing. Just know that that's the class name of one of those motors. Next, we pass in some argument here. 2. What is 2? 2 is the ID of the motor. So every motor on that robot has an ID, and we're going to need to pass that in for it to know which one to control. Finally, we also need to tell it which type of motor it is, because those motor controllers can control both a brushed or a brushless motor. And we're always going to be using brushless, but it's important that it knows which one it's controlling. So now that we have our motor, we can set it to go to a certain speed. Right, it's pretty simple using the .set method. We pass in 0.5, for example, 50%. 0.1 is a pretty good starting place. We don't want to destroy anything, damage anything, and that thing could damage things if it goes too fast. So we want to be careful with those speeds. And then we can also add a minus sign in front of it to make it go the opposite direction. Then finally, we can also get things from that motor controller. So, for example, here we're getting the motor temperature, which is an integer, and it's printing that out. Okay, that's just one of the many things that you could get, but these are some of the different ways that you can control a motor. Okay. Next, let's look at some sensors. So I'm not going to go through all these different sensors. There are a lot of them that we use in FRC, but the 2 ones or 3 ones that I'll talk about for a second are the ones that actually exist on this robot. Okay. So for one, this is a proximity sensor. So this will detect when something gets within a certain range, and that uses infrared light to do that. That's very useful for knowing if there's a ball in the robot, something like that. Then we also have something called an encoder. So in each of those motors, there's an encoder that tells us how far it's going and like how many rotations it's done and how fast it's turning. That can be useful too. And we also have something called a gyro, which tells us the direction that the robot's facing. That's not going to be useful yet, but in a few weeks you'll find that useful. That's just a couple of the different sensors that we look at. And then let's look at how we actually use one of those sensors. So the sensors we're using today are digital sensors because they're plugged into a digital port. But we can use either an analog or digital sensor. So an analog sensor is going to return any one of a range of values, right? It can vary in all kinds of different ways. So the way we do that is we use the analog input class to make an analog input variable, and we would pass in the port on the RoboRio, which is the computer that runs the robot. We can get the value from the sensor, we can get the voltage from the sensor, and that kind of depends on the sensor what values you're going to get back. Today we're actually using this as a digital input, so we're going to pass it the port on the robot reader, which I'll show what that looks like in a second. And then with that, we just do .get. So that will return a Boolean telling us whether or not the sensor sees something or not. Now, a tricky thing about this particular sensor is that if you have your hand in front of it and it's close enough to activate it, the light will go on, right? So what value do you think that should return? Like what Boolean value? It's not a trick question.
True.
True? Is that what you said? Very logical. Okay. Nope, this one doesn't. This one returns false if it gets turned on. And if you have your hand too far from it, it will return true. So that's one way you would want to put a not in front of it, like with one of those exclamation marks in front of it. I don't know why, but that's that particular sensor. So that's just something to look for because you will be using that sensor later today. All right, let's move on. So this is pretty much your first example of actual running code that will do something on the robot. And this is actually something you're going to be doing today, later on. No need to memorize this because you'll have to figure it out later. So the way we interface with these joysticks, and if you look there, the big black and orange joysticks on the table there, we're going to be using those. And those are called joysticks. But every controller that we use that's plugged into the computer is called a joystick in our code. So that's the class called joystick, and it has an ID. There's a way to know which ID you're going to be using, but for today you're just using 0, so it doesn't really matter. It's just going to be the leftmost joystick. And then we're also going to be making a motor on ID 1, just the same stuff we've been looking at. But then we have this teleop periodic. So first, we're in a file called robot.java. You'll see this in a minute when we actually get started with this. But robot.java is where pretty much all the magic happens, at least at the beginning. When you're first programming a robot, all the code's going to be in this robot.java file. And it has a bunch of different loops that run at different times during the life cycle of this robot. So what does teleop stand for? Teleop means teleoperated. So that means when we're actually driving the robot, and when the robot's enabled so we can drive it, this runs periodically. So it'll run, this method will run every 20 milliseconds as long as the robot's enabled. Okay? So what are we doing inside of there? We're using myMotor.set. Remember, that's how you set the motor to run at some % output. And then we do myJoystick.getX. So what does that do? Well, on that controller, that means moving it side to side. That's the x-axis, right? The y-axis is forward back. There's also a z-axis for twisting, but we're not going to use that. But just the x-axis means side to side. And it's going to go between -1 and 1. So that fits pretty well because the myMotor.set takes in a %. So it's going to get the value that you have the joystick at, and it's going to give that speed to the motor. Right? Maybe it makes more sense to you to make it the y-axis. You push it forward and it runs the motor faster. You push it back, it moves slower. But that's just one way you could control it with a controller. And then we're going to look at one more example right here. So we can also detect that a button's pressed. So maybe while you hold down a button, you want the motor to move, that kind of thing. So we have, we make our joystick again like we did before. So this time, you could put joystick button here. Doesn't really matter, but we make a button, and it's of type joystick button. And it takes two things. It takes my joystick, right? That's the joystick we already made. And it also takes a number. That every button on the entire controller has a number. They're not labeled. So I'll show you how to figure that out, which button you want to press, because every single one has a different number. And then finally, we can actually get that value as a Boolean. So that's what that method right there does. So if you have the button pressed down, it will return true. Otherwise, it will return false, which is a lot more logical than that other sensor. Okay, so now it's time to actually get to the good stuff. So from now on, we're actually going to be doing stuff. So this is just the first step, but we're going to get to labs in a minute. So has anyone not installed WPI, lib, and Git on their computer? Because I put that on Discord. So everyone has that? Okay, so that's good. So if you've already done that, what you're going to want to do is actually get ready, open up your computer, okay? And we're going to want to get started with the skeleton project. So for anyone who is extra experienced, you could technically start from scratch, and if you ever program your own robot, you would. But for now, we're going to use a skeleton project that's going to give you a good starting place to make this a little bit easier so we can get started faster. So I'll give you a minute to get that up and running. Anyone need to get on the Wi-Fi? So next we're going to be doing the lab. So every day is going to look like this. Not every day, but once a week. It's going to look like this. We're going to have the lesson, right? And then the lab. Hopefully the lessons in the future probably aren't going to be this long, or not quite this long. But the lab is now your opportunity to actually code. So there's going to be there's one robot, one driver station to control the robot, and 7 of you. So you're going to be taking turns. But luckily it's your first time, so hopefully you'll make mistakes and it won't work every time. So you'll be able to share. But anyway, I'm going to first, after I explain everything, I'm actually going to give you a little tour of the robot, then you're going to get working. So let's move on so we can actually see what these labs are going to look like. So first, here's the QR code for the presentation. We're going to leave this up, okay? Obviously, I don't expect you to have memorized every single thing you saw in the presentation. That's not expected. If you need to refer back to that, you can always scan this and see what we looked at. So there's going to be 3 things for today. You aren't required to do all 3 of them. The goal is just that you get as far as possible, right? You have to take turns on the robot, etc., etc. So it's okay if you don't get everything done. Just try your best. Our goal is really for you to learn, so it's okay if it's not everything. So the first one is going to be running a motor, one of the motors on that robot, until that sensor is activated, that proximity sensor I was talking about before. So that's going to involve a digital sensor, digital input, remember that's the name of the class, and that spark max for the Neo motor on the robot. So your logic is going to always go in teleop periodic for all of these, so that's where you need to be looking, okay? Then the next one's going to be running a motor while the button is pressed. Okay, I'm just going to go through all of these, then I'm going to show you the robot, so you don't need to get started yet. So you want to hold down one of the buttons on the controller, and when you're holding down the button, we want it to be driving, or spinning that one motor, and then when you let up, we want it to stop. Then, finally, we're going to be controlling the motor speed with the joystick axis. So that's what I was showing before, where you move the joystick forward and backward, or side to side, and one of the motors spins forward or backward at whatever speed you're giving it from that joystick. Now, if you get done with all of those, you can actually move on to maybe making the thing drive using both joysticks with 2 motors, which is definitely feasible. But we're going to get started with this. I'm going to write some important information up there on the whiteboard. It's just going to be a couple of different, like motor ID, the motor ID, and like the sensor ID, and the joystick ID. But here, come over here for a second so I can give you guys a tour real quick of the robot, because this is most of your first robot. Micah, you want to come over as well?
Yeah, sure.
So this is the robot. This is your best friend for the next few weeks. It'll probably also be your main enemy. So this is called tank drive, right? Notice how we have 3 wheels on each side. That's called tank drive, right? So all it does is forward, backward, turning. It can go in different ways like that. There's 4 motors. Anyone want to point out a motor to me? Come up. I know there's at least 2 of you that should know what a motor looks like. Yeah, that is a motor.
Great job.
What a genius we've got here. So these 4 are all motors right here. And so that means that this side is controlled by 2 motors. This side is controlled by 2 motors. These motors both go in the same direction. So if we drive both of these motors in the same direction, it will go forward. Actually, this is forward. If we both drive both of these in the same direction, this will go forward. Okay? Notice that if I drive both of these forward, and I drive both of these forward though, because they're on opposite sides, that would actually make it spin. So we actually need to invert the direction of the motors on this side. This is not something you have to worry about for today. But I'm just pointing that out because they're on opposite sides. Forward is opposite on both sides. Next, we have this sensor right here. Okay, so this is that proximity sensor I was talking about earlier. Once we turn it on, you'll be able to go like this. You'll be able to see this light on the back turn red when you get close enough. And that's plugged in right here on the Robo Rio, which is the computer. This thing right here is the computer that runs the robot on DIO 0, meaning digital input. Okay, so it's on ID 0 there. Each of these are motor controllers, and they're all taped with their labels, telling you which one is which. So that's just the IDs there. And next, we're going to turn on the robot. So any brave volunteers want to put in the battery? Okay, these are really advanced skills. I'm just, obviously just joking. So the battery goes in, but just not that way. It goes the other way. So leads will go this way. So we want it in here, inside the phone. Okay, and yep, you can plug it in. Now we want to put on this Velcro strap. So you feed it through down there. Okay. Oh yeah, we did make it tight because it was a very quick idea to put in the Velcro. And now we need another volunteer to actually turn on the robot. Who wants to turn on the robot? Brave soul. One of these other advanced skills. Yeah, why don't you come over? So this is the power switch right here. So to turn on the robot, you're going to want to pull this in. So it's going to go this way in until it clicks, and then all the lights will go on. Nice. If you wanted to turn it off, you would press that down. We're not going to do that right now, though. Cool. So the robot's on now. So that means the sensor should also have power, which means that if I go like this, if you see that LED turning on, right? If I go like that, right, it can see it. Okay? So that's what you're working with for today. Feel free to ask questions, scan the QR code, and get started on your code. I'm going to write up a couple of important numbers on the board, and hopefully you feel prepared enough to do at least something within the next hour. So go ahead.